A very good day to all of you. We are going to continue the solutions of second order differential equations from the previous lectures, where we have stopped for the solution of first order differential equations. Okay. Example 1. Solve the d2y dt2 minus 3 dy dt plus 2y equal to 2 exponent 3t given the initial condition y0 equal to 5, means t0 y equal to 5, and when t0 y prime t equal to 7, or y prime bracket 0 equal to 7. Okay, similar with first order differential equation, to solve it by Laplace transform, first step takes Laplace transform at both hand side. First step, taking Laplace transform at both hand side. Okay, and for left hand side, using linearity property, hence you have the Laplace transform for second derivative minus 3 times Laplace transform for first derivative plus 2 times Laplace transform for y equal to Laplace transform for 2 exponent 3t. Okay, as we know that in the previous lectures, Laplace transform for first derivative, you have s ys minus y0. Laplace transform for y double prime t of second derivative, s squared ys minus s y0 minus y prime 0. So for first derivative, here you have s squared ys minus sy0 minus y prime 0. Okay, first derivative minus 3 sys minus y0. Laplace transform for y ys. So Laplace transform for 2 exponent 3t is 2 over s minus 3. Second step, plug in the initial condition. Okay, given y0 here is 5. So y0, you put it here, 5. So here 5. Okay. So total like minus 5s. Y prime 0 given is 7. So here put it 7. After that, solve for ys. So left side, notice that this is your, here you have ys. Collect the ys term. ys. Okay, factor out ys. So first term here still have s squared, here negative 3s, here plus 2. Let's collect all the ys term. The term without ys bring to right hand side. So here, this one, minus 5s minus 7. So bring to the other side, so you have positive 5s. Here minus 7, then this one you have minus 7. So negative 3 times negative 5, so you have plus 15. So total is, this one is equal to 8. 8 you bring to the other side, right side become minus 8. Okay, and then 5s minus 8, you compose with this fraction into one fraction. So you have 2 over s minus 3. So 5s minus 8, want to combine with s minus 3. So you have to multiply here s minus 3. And then you have to divide by s minus 3. So same denominator term, you can combine. So that's why 2 over s minus 3 plus 5s minus 8. Make sure you have bracket, final bracket, s minus 3. And then left side, the s squared minus 3s plus 2, can factor it, become s minus 2 times s minus 3. And then for third step, solve for ys. That's why you want 1 time of ys. That's why the term multiplied by s minus 1 multiplied by s minus 2, bring to the other side, become divide by s minus 1 and s minus 2. Okay, and then you simplify the numerator, 5s squared, so bring the 2 and 24 collect together, so total is 26. And then we factor out the numerator, become 5s minus 13 s minus 2. You can simplify or cancel out the term s minus 2. So just left 5s minus 13 for numerator. Denominator left two linear term, s minus 1 times s minus 3. So fourth step, take the inverse Laplace at right hand side. So the inverse Laplace for RIS at the left side you get 1t. The inverse Laplace for 5s minus 13 over s minus 1 over s minus 3 can be solved either using partial fractions or convolution theorem. Okay, in this case we solve it using partial fraction. Notice that the denominator have two linear terms. Hence we decompose it into two fractions of a over s minus 1 plus b over s minus 3. And then we compare the numerator after the cross multiplications. So you have a times s minus 3 plus b times s minus 1. Because you have left side, right side the same denominator. We just cancel it and then we just compare the numerator. So 5s minus 13 equal to a times, make sure bracket, a times the whole group s minus 3 plus b times the whole group s minus 1. Okay, against for linear term, okay, we can substitute the s equal to 3. Because 3 minus 3, this term is 0. Then can solve for your b, which is 3 minus 1, we have 2b. Okay, and then for left side, 5 times 3. 15 minus 13 you get 2. So 2 equal to 2b, hence b equal to 1. Okay, and then later on for the linear term s minus 1, okay, we plug in s equal to 1. S equal to 1. So 1 minus 1, the b term gone. Then you can solve for the a term. The a term, which is 1 minus 3, which is negative 2a. And then 5 times 1 is 5 minus 13, which will be negative 8, equal to negative 2a. Hence a equal to 4. So the 5s minus 13 over s minus 1 over s minus 3 equal to 4 over s minus 1 plus 1 over s minus 3. Okay, and the inverse Laplace for 5s minus 13 over s minus 1 over s minus 3 is equal to the inverse Laplace of 4 over s minus 1 plus inverse Laplace of 1 over s minus 3. So the inverse Laplace for 4 over s minus 1 you get 4 exponent t. The inverse Laplace for 1 over s minus 3 is exponent 3t. Okay, hence the yt is actually the inverse Laplace of 5s minus 13 over s minus 1 over s minus 3 and equal to 4 exponent t plus exponent 3t. Now we move to the second example. Solve the d2y dt2 minus 4y equal to 24 cos 2t given that y0 equal to 3 and y prime 0 equal to 4. Okay, first K takes the Laplace transform for left side, right side. So Laplace transform for left side, by applying the linearity property, then you find the Laplace transform for second derivative. Second derivative will give s squared fys minus sy0 minus y prime 0. Then for second term, minus 4 Laplace transform for y, you get ys. Okay, right side Laplace transform for 24 cos 2t is 24s over s squared plus 4. Okay, second step, put in the initial condition y0 equal to 3. So this term we got minus 3s and y prime 0 equal to 4. So you have minus 4 ys. Third step, solve for ys. Okay, then you factor out the ys term at the right hand side, left hand side, sorry. So ys, so bracket, this term we have s squared, okay, and then we have one more, factor out ys, so we have minus 4 here. So the term without ys, bring it to right side, so it becomes 3s plus 4, okay, this side of the initial 24s over s squared plus 4, and then, okay, 3s plus 4, okay, we multiply by s squared plus 4, okay, s squared plus 4, and then we divide by s squared plus 4. So same denominator term, s squared plus 4, so we can combine these two fractions at their numerator. So 24s plus 3s plus 4 bracket and bracket s squared plus 4. Okay, because we want 1 ys, that's why the s squared minus 4, okay, is equal to s minus 2 times s plus 2. This one is actually equal to s minus 2 times s plus 2. Okay, so that's why the ys is 24s plus 3s plus 4 times s squared plus 4 divided by s squared plus 4. Okay, these two terms is actually come from the s squared minus 4. This is multiplied, bring to the right hand side, become divide by s minus 2 divided by s plus 2. And then we expand the second term at the right side, expand it, and then we simplify it. So we have 3s cubed, we got 24s plus 12s, so we have 3s cubed plus 4s squared, so 24s plus 12s, 36s plus 16, over s squared plus 4 over s minus 2 over s plus 2. So lastly, the fourth step takes the inverse Laplace transform for ys. So you get yt. To get yt, hence you need to find the inverse Laplace of 3s cubed plus 4s squared plus 36s plus 16 over s squared plus 4 over s minus 2 over s plus 2. Again, we solve it using partial fractions. Okay, notice we have three factor. The first factor is quadratic factor, s squared plus 4. Hence, its numerator must be linear term, as plus b. As I said, numerator must be always 1 degree lesser. So if the denominator is a quadratic, the numerator must be linear term, as plus b. Then for the second factor, linear factor, s minus 2. So the numerator is c, because I have a, b, and then you see the last factor, s plus 2, become b over s plus 2. Okay, by cross multiplication and comparing the numerator term, so you have 3s cubed plus 4s squared plus 36s plus 16 at the left side equal to, okay, notice the first term as in our previous lecture, okay, on the partial fraction. So for the quadratic term, as plus b, we already have the s squared plus 4. We don't have s minus 2, s plus 2. So mean as plus b need to be multiplied by the other two factor. As plus b, you have here. You don't have the other two factor, s minus 2 and s plus 2. So you multiply by here. Okay, and then for b, sorry, for c, we have s minus 2, but we don't have s squared plus 4, s plus 2. That's why for the c term, need to be multiplied by s squared plus 4 and s plus 2. Okay, for d term, we have s plus 2, but we don't have s minus 2. That's why d term multiplied by s squared plus 4 multiplied by s minus 2. Okay, I repeat, it's actually very easy. Okay, as plus b multiply with the other two factor at the denominator. Okay, that's why as plus b times s minus 2 times s plus 2. For c, the c term, okay, the c term is here. C, we multiply like this, c. S squared plus 4, s plus 2. Okay, and then for the d term, okay, d, d, you need to multiply this one, you need to multiply these two. S squared plus 4, s minus 2. Okay. Then, so let's see that a term, this one multiply this one multiply this. As plus b times s minus 2, s plus 2. Okay. I put it different color. You can see it clearly. Okay. C here. Extra bracket. And then this one. C times s squared plus 4 times s plus 2. Okay, d, d multiply this one, s squared plus 4 here, s minus 2. Okay. After that, we compare the numerator and right hand side. Okay, we have the, okay, first of all, you have the linear term s minus 2, s minus 2. You may substitute s equal to 2. Yeah, 2. So 2 minus 2, this is 0. So 0 times anything, the whole term gone. Okay, so here, if you 2 minus 2, this is 0. The whole term becomes 0. Okay, we look at the right side first. Then s by 2. So 2 squared, you have 4. 4 plus 4 is 8. 8 times 4. So you have 32c. 32c. Okay, and plug in s equal to 2 to your left side. Left side, maybe you can use a scientific calculator to calculate it quickly. Okay, I'm going to put in the here as a formula. We got 3. Put it as I put it as an x cubed plus 4 x squared plus 36 x plus 16. Then I can see. 3x cubed plus 4x squared plus 36x plus 16. I'm going to calculate here. You want s is 2, or in the calculator we don't have s, I put it as x. So you have 128. So 128 equal to 32c. So c is 128 divided by 32, which give you 4. Okay, I erase first. Okay, and then later on, you notice that we have, okay, the term s plus 2. So we substitute s equal to negative 2. So negative 2 plus 2, we got 0 times anything 0. So this one negative 2 plus 2. So the whole term 0. Then you can calculate for d. Okay, negative 2. So negative 2 squared is actually 4. So 8 times. So actually you got 4 plus 4, 8. Okay, negative 2 minus 2 minus 4. So total is minus 32d. Minus 32d for the right hand side. So for left hand side, okay, you can use back your calculator where you have input the formula just now. 3x cubed plus 4x squared plus 36x plus 16. Now calculate for the s equal to negative 2. You calculate, of course in your calculator you don't have s, you use a x. So negative 2, so we get negative 64. Negative 64. So negative 64 equal to negative 32d. Hence d is negative 64 divided by negative 32, which give you d equal to 2. Okay, then I erase it first, okay, to calculate for the rest of the parameter. Okay, we notice we have only two linear terms s minus 2, where we substitute s equal to 2, s plus 2 we substitute s equal to negative 2. Okay, and then we don't have any more linear term, and then the easy way is let s equal to 0. Because if s 0, the right side is just left, and left side is just left 16. Okay, and then the right hand side, okay, when s 0, let's look at here, the last term first. So we have d times 4 times negative 2, which is negative 8d. Okay, for the c term, s is 0. So c times 4 times 2, so means it's 8c. Okay, for the first term, s0, so this term gone, this term gone, this term gone. Means you have b times negative 2 and then times 2. So means total is negative 4b. So 16 equal to negative 4b plus 8c minus 8d. You want to find for b. So I bring to left side, so become positive 4b. 16 I bring to left side, so minus 16 plus 8c is 4. So 8 times 4, 32. D is 2, so minus 16. So minus 16 minus 32 plus 32, that's why B you get 0. Okay, and lastly, to find the last parameter, okay, normally we can use the highest degree term, because easy, okay, you can easily get the highest degree term rather than expand all the expression at your left hand side. Okay, and then okay, the highest degree term in this case will be only we have here as times s times s in here. As times as squared, and then multiply again with s, so as cubed. As cubed, so the coefficient will be a. Okay, for left side, s cubed is 3. Coefficient for s cubed is 3. Okay, and then for the c term, notice c times s squared. We expand the first term only. Cs squared times s, cs cubed, so it's c. Okay, and then the last term ds squared multiplied with s, so it's ds cubed. Why we take the highest degree term? Because we just multiply the first term. If it takes a middle like linear term, then you need to expand everything and collect it. So we always take the highest degree term and always let s equal to 0, because easy to calculate with s equal to 0. Okay, and then plug in the plug in a that we are going to find. Plug in c here. C is 4, d is 2, so 4 plus 2 is 6, so a is 3 minus 6, okay, where you get negative 3. So this one is actually as. A is as plus b, but b is 0, that's why I get negative 3s over s squared plus 4, because b is 0. As plus b plus c, 4 over the second factor, which is s minus 2, plus d is 2 over the last factor, s plus 2. Hence, the inverse Laplace of 3s cubed plus 4s squared plus 36s plus 16 over s squared plus 4 over s minus 2 over s plus 2 will be equal to the inverse Laplace of here, negative 3s over s squared plus 4, plus inverse Laplace of 4 over s minus 2 plus inverse Laplace of 2 over s plus 2. So for the first term, the inverse Laplace of negative 3s over s squared plus 4, you get negative 3 cos 2t. For second term, you get 4 exponent 2t. Okay, the last term, you get 2 exponent negative 2t. Hence, yt is equal to the inverse Laplace of this fs and equal to the negative 3 cos 2t plus 4 exponent 2t plus 2 exponent negative 2t. So in conclusion, to solve your first order or second order or differential equation by Laplace transform, first step takes the Laplace transform in left-hand side. Second, plug in the initial condition. Third, solve for the ys. Okay. Lastly, takes the inverse Laplace transform to obtain yt, where the Laplace transform for yt is actually ys. Laplace transform for y prime t is s ys minus y0. Laplace transform for second derivative is s squared ys minus sy0 minus y prime 0. Okay, with this, thank you for your attention and watching this video.